Prior to it happening, many experts and governments in the United States informed the public that a computer bug known as Y2K might shut down the world's systems, causing a global collapse. It has also been called the Y2K scare, Millennium Bug, Y2K glitch, Y2K, and others. These errors are related to how calendar data is formatted and stored. Y2K is a term that stands for year 2000 and was commonly used to refer to the software problem that occurred during that time. The issue was commonly referred to as the Millennium Bug because people associated it with the transition to the new millennium, even though the problems could have happened at the end of any century. In the past, certain programs would only display the last 2 digits when representing years with 4 digits. There was confusion because it was hard to determine if a year like 2000 referred to the actual year 2000 or the year 1900. Computer systems' inability to accurately recognize dates had the potential to cause major disruptions to global infrastructures in industries that heavily depend on computers. From the 1960s to the 1980s, computer engineers used a 2-digit code for the year to save on expensive storage. As the year 2000 approached, a seemingly minor decision had unexpected consequences. Many people believed that the world would completely shut down when the clock reached midnight. In the years before the year 2000, some individuals went to great lengths to prepare for potential problems. This included constructing shelters and gathering supplies of food and water. The main problem was that computers, including both mainframe and personal computers, were unable to differentiate between the years 1900 and 2000. There was a concern that computers might mistakenly interpret the change from December 31, 1999 to January 1, 2000 as a transition from December 31, 1999 to January 1, 1900. This glitch had the potential to disrupt various sectors, from financial institutions calculating interest rates to power plants relying on accurate date information for safety checks. The Y2K bug became a global concern, especially as it coincided with a time when technology was becoming increasingly integral to various industries. Financial institutions, running on dated computers and technologies, raised concerns about a possible seize-up of the banking system. The ripple effects of such a scenario could lead to a cascade of panic and economic turmoil on an international scale. The problem was discussed in the early book Computers in Crisis by Jerome and Marilyn Murray Petricelli in 1984, and was later reissued by McGraw-Hill in 1996 under the title The Year 2000 Computing Crisis. The first recorded mention of it on a Usenet newsgroup was made by Spencer Bowlus on January 18, 1985. The acronym Y2K is said to have been created by a programmer named David Eddy from Massachusetts. He mentioned it in an email sent on June 12, 1995. He later mentioned that people were referring to it as CDC, century date change, and FADL, faulty date logic. The issue arose because memory was costly on both mainframe computers and, later, personal computers. Prices averaged about $55 per kilobyte in 1975. That's $57,671,680 per gigabyte. You can see the problem here, so it was crucial for programmers to reduce usage. Computers became widely used in the 20th century. To save storage space, programs could add 19 as a prefix to the year of date and store only the last 2 digits instead of all 4. Due to the high cost of disk and tape storage, these strategies were implemented to save money by reducing the size of stored data files and databases. However, a trade-off was made as the data became unusable after the year 2000. But you see, the Y2K bug was not merely a theoretical concern. In fact, in the years leading up to the turn of the century, documented errors and glitches served as signs, from incorrect electric bills in Illinois to malfunctioning taxi meters in Singapore and Sweden. On February 8, 1999, a technician at Peach Bottom Nuclear Generating Station made a mistake while testing Y2K compliance. Instead of resetting the time on the external computer used to simulate the date rollover, they accidentally changed the time on the operating system's computer, which monitors nuclear core rods. The computer had not been upgraded yet, and when the date was changed, it caused all the computers at the station to crash. It took about 7 hours to restore all normal functions. During this time, workers had to use outdated manual equipment to monitor plant operations. These incidents hinted at the potential chaos awaiting the world on January 1, 2000. In Australia, the ticket dispensing machines at 13 train stations experienced a temporary malfunction because of the Y2K bug. The glitches caused delays and frustration for commuters, showing how transportation systems can be vulnerable to these issues. There were concerns when the Y2K bug caused issues with the radiation monitoring equipment at the Shika nuclear power plant. Officials have reassured the public that there is no danger of radiation leaks, and no rise in radiation levels has been found. The Osaka media port experienced data management errors in their network just after midnight on January 1, 2000. The problem was fixed in just 2 hours and didn't cause any problems, but it showed that there could be Y2K-related issues in important communication systems. The Y2K bug caused problems in Australia and Japan, specifically in the transportation and communication industries. Although the overall impact was not as bad as expected, it reminded us of the importance of being prepared and planning for potential technological issues. Japan's largest cellular operator, NTT Docomo, reported disruptions in some mobile phones. These devices, instead of deleting older messages as intended, were inadvertently deleting new messages as the memory filled up. In the financial sector, 15 securities companies in Japan encountered glitches in trading programs. Thankfully, officials reported that 14 of them managed to resolve the issues within a day, mitigating potential financial disruptions. South Korea also faced Y2K-related issues, such as the malfunctioning of Ondol heating systems and water heating at an apartment building close to Seoul. Hospitals in Gyeonggi Province have reported problems with their equipment. These issues have resulted in incorrect information being recorded, such as newborns being registered with birth dates from the year 1900. Greece experienced numerous problems, affecting a large part of the population, with an estimated number of 30,000 cash registers printing receipts with dates in 1900, impacting businesses across the country. Germany encountered payroll system errors at the Deutsche Oper Berlin, where the system interpreted the new year as 1900. The complications arose when trying to determine the ages of employees' children, which led to the incorrect withholding of government childcare subsidies. In a similar incident, a bank in Germany mistakenly transferred 12 million Deutsche Marks to a customer, along with a statement dated December 30, 1899. The computers in courthouses in Venice and Naples, Italy, were showing incorrect release dates for prisoners, displaying January 10, 1900, as the upcoming release date. Mistakenly, some prisoners were given an extra 100 years added to their sentences. The reported problems were one of the reasons why many people believed that the world would end. They also served as real-life examples of the challenges caused by the Y2K bug despite the extensive preparations made. As governments and organizations scrambled to address the impending Y2K crisis, millions of dollars were poured into IT and software development. Special committees were established to monitor remedial work and contingency planning, focusing on critical infrastructures like telecommunications, utilities, and transportation. Despite the initial panic and uncertainty, the Y2K transition into the new millennium was surprisingly smooth. This outcome was attributed to the tireless efforts of computer programmers and information technology experts globally. Governments, businesses, and organizations collaborated on a massive scale, checking, fixing, and upgrading their computer systems to address the Y2K problem. Most people agreed that the extensive efforts to fix the problem around the world were very important in preventing the expected disaster. Various programming solutions were used to address the Y2K problem. These included expanding dates, creating date windows, compressing dates, reorganizing dates, using software kits, upgrading real-time clocks, and implementing bridge programs. Every method had its own benefits and difficulties, which made the process more challenging. To address the Y2K problem in legacy systems, diverse programming solutions were implemented. These solutions aim to ensure seamless transitions into the new millennium. The most straightforward solution was to expand 2-digit years to 4-digit years in programs, files, and databases. This method was clear and permanent, but required significant effort in modifying and testing entire systems. Another approach was to retain 2-digit years but add code to determine the century dynamically. This method was less costly since it took up less hard drive space and was easier to implement but was not a permanent fix. Some systems used a method to compress dates into binary numbers, allowing for efficient storage while avoiding the Y2K issue. In cases where database sizes couldn't be changed economically, a method was used to convert dates into a format that delayed the problem to a much later date. Various software kits were developed to address the Y2K problem in personal computers. Some solutions worked at the BIOS level, while others, like Y2000 RTC, functioned as device drivers. There was also the use of bridge programs to manage date fields and systems, ensuring correct data handling. Implementing solutions requires a significant amount of work from governments, businesses, IT professionals, and individuals. To ensure a smooth transition, we had to conduct thorough testing, convert data, and upgrade the system. The estimated cost for fixing the Y2K issue worldwide was a staggering $308 billion US. When all the nerves were finally calm on the Y2K matter, various people started to view it differently. People who supported the view that the government did all in its power and spent numerous resources to combat the Y2K problem argue that the vast majority of problems were successfully rectified, justifying the substantial financial investment. They contend that the lack of major issues during the date change indicates the effectiveness and completeness of the Y2K remediation project. The extent to which larger industry and government fixes averted potentially significant impacts remains somewhat undisclosed or underreported. An interesting perspective suggests that the redundant networks established in preparation for the Y2K bug impact played a role in ensuring the continuity of infrastructure operations during the terrorist attacks on September 11, 2001. This included crucial services like subways, phone systems, and financial transactions. Contrary to the supporting view, skeptics agreed that there were either no critical problems or only a few minor mistakes to begin with. International Data Corporation estimated that the U.S. might have wasted around $40 billion on Y2K remediation efforts. Critics of the massive undertaking pointed to the absence of Y2K-related problems before January 1, 2000, questioning the need for such an extensive effort. Estimates suggested that approximately 25% of all Y2K-related problems should have occurred before the turn of the millennium, but their absence raised doubts. Countries like South Korea, Italy, and Russia, which invested little to nothing in Y2K remediation, experienced negligible Y2K problems. This contrasted sharply with the expectations in Western countries, where severe problems were anticipated in Russia to the extent that travel advisories were issued and non-essential staff were evacuated. Looking back, the problem seems so silly. With the amount of data computers can hold now, the problem almost seems comical. What do you think? If you enjoy our independent journalism, consider subscribing. Thanks for watching.